Okay, so first thing I'll do is just some a little bit of housekeeping. In order to access the recordings, to directly access the recordings, here are the actual steps that you can go through. Okay, give me just 1 second as I situate all of my screens. Okay, when you're in the Blackboard course, once you click on virtual recordings, once you click on virtual class, you're in the Blackboard Collaborate Ultra sessions. The 3 little parallel bars, if you were to click those, the very last link is recordings, and here you can actually find the recordings. So just in case the videos in this recorded virtual classes aren't working for some strange reason, you can direct them, you can access them directly through the virtual class. Okay, so today we're going to continue in chapter 3, and I believe the last time that we left off we were talking about the standard deviation, and we found the standard deviation by using a calculator, even though there is a formula. Okay, a lot of the statistics functions can actually be done with a calculator. So we looked at a data set and we calculated the standard deviation of a data set. Now we're going to calculate the standard deviation of a frequency distribution. I'm actually going to go into the homework. And we will take a look at problem number 17. And I just want to make sure that my calculator is visible, and it is. Okay, so in this example, we're given a frequency distribution. We're also given a formula. Now notice this formula is a little bit different than the formula for the standard deviation of a data set. Okay, if you're dealing with a frequency distribution, right, and in this distribution, we're really not given what our data represents, but we're given the interval. And in our first class, 20 to 29, second class, 30 to 39, third class, 40 to 49, the next class, 50 to 59, and so on. And in our last class is 80 to 89. And we're also given the frequency for each class. Now, how do we calculate the standard deviation? Well, just as we calculated the standard deviation, just as we calculated the mean of a frequency distribution, meaning that we found the midpoint for each interval, and we use a calculator, we put that in list 1. We put the frequency in as list 2, and we use the one variable statistics. We'll do the exact same procedure to find the standard deviation of a frequency distribution. All right, so using my calculator, right, the first thing you want to do is you want to calculate the midpoints for each one of your classes. So let's say if I wanted to calculate the midpoint for the first class, I would simply add my upper and my lower limit, and I would divide by 2, right, and I get 24.5. I would do the same thing for all of my classes. So if my math serves me correct, I believe for our first class, the midpoint will be 24.5. Since each class is with 10, I'll simply add 10 to my first midpoint, and that should give me the midpoint for my second class. If I add 10 more, that would give me the midpoint for my third class, and so on and so forth. Right, so the midpoint for my first class is 24.5. The midpoint for the second class is 34.5, and so on until I get the midpoint of my last class, which is 84.5. So I'm going to enter those values into list 1. So using the calculator, in order to make any changes in our list, I'm simply going to hit Stat, and we want to edit our list. So since edit is highlighted, I'm going to hit Enter. If you have data that's already in your list, to clear out the data, you can simply go to the top of the list. You can hit Clear and Enter. I'm going to do the same thing for list 1. Clear and Enter. Okay. So you want to make sure that you're specifically dealing with list 1 and list 2. Now notice you have a Ti84 calculator, and I'll pull that up in just a second. The function itself is actually different. All right, so we're going to enter in the data. So I'm going to put in my midpoints. And my last midpoint, 84.5. All right, so I have in all of the midpoints. The next thing I'm going to do is for list 2, we're going to put in the frequencies. All right, so I have in all of my frequencies. Okay, and from this time, I'm going to go return to my home screen. So I want to hit second and quit, which is the home screen. And I'm simply going to clear everything out. Next, in order to calculate the standard deviation, and also if you wanted to calculate the mean, I'm going to go back into Stat. I'm going to scroll over to Calculate. I want to calculate the one variable statistics. And this is where the function may be different if you're using the Ti84. For my one variable statistics, I'm going to put in list 1. So I'm going to hit second and 1, which is list 1, comma, list 2, and I'm going to hit enter. So what we're actually seeing here, we have X bar, which is the mean, which is 74.2, and I want the standard deviation. So notice that's S of X, which is the sample standard deviation, is equal to 14.46, and we're going to round that to 14.5. All right. If you are using the 84, and I'm going to bring up the document camera. If you're using the Ti84, so you would put the data in the exact same way. Okay, you want to specifically make sure you're working with list 1 and list 2. So if I put those numbers in again, for list 2, I'm going to put in the frequencies, which are 2, 4. All right, so I put all of my data in the list 1 and into list 2. Okay, I'm going to go to my home screen. I'm going to go in the stat, and we're going to calculate the one variable statistics, and this is where it looks a little bit different. So for list, I'm going to put list 1, right, again, that's second and 1. For frequency list, we're going to put in list 2, and we would calculate, and then notice our standard deviation is 14.46. So same value, we just calculate a little bit different. Okay, now there is a second part to this problem, and it says consider a difference of 20%. Okay, and you've probably seen this in a couple of problems. One, I believe one says 5% difference and that sort of thing. Okay, this is how you handle these problems. This says consider a difference of 20% below two values of the standard deviation to be significant. How does this computed value compare with the given standard deviation of 11.6? Okay, so we calculated a standard deviation of 14.5, and it says that the standard deviation we're comparing that to is 11.1, and we want to know if a 20% difference between the two is significant. So first off, I'm going to find 20% of 14.5. So I have 14.5 times 0.2, right, which is 2.9, right? If I add 2.9, so that's my 20% of 14.5. If I were to add 11.1, and if I were to add this 20% difference, I get a 14. Right, so I took 20% of 14.5, and I got 2.9. And I was given this standard deviation of 11.1. When I add the two together, I get 14. Notice that my value is 14.5, which is greater than the 20% difference between the two. So my answer for the last part, it says the computed value, which is this 14.5, is significantly greater than the given value. All right, so once again, I took 20% of 14.5. I added that to 11, and I compared that number, which is 14, to my deviation. And notice that our calculated standard deviation is higher than the 14. All right, so that's problem number 17. Okay, how you calculate the standard deviation of a frequency distribution. All right, so I'm gonna pull the calculator down. All right, there's also something called the range rule of thumb for a standard deviation. And what this gives you is a quick and dirty way to calculate a standard deviation. Okay, versus going through the formula and calculating a standard deviation, we can use what's called a range rule of thumb, okay, which is a less intense calculation in order to find the standard deviation. So it says that the range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. The vast majority, such as 95% of the sample values, lie within 2 standard deviations of the mean. Okay. So the range rule of thumb for identifying significant values says that it's significantly low if the values are mu, and keep again, mu is the population mean, and x bar would be the sample mean. And this sigma, that's the population variance. So these are actually given to you with population parameters. So significantly low values are mu minus 2 times the standard deviation. Significantly high values are mu plus 2 times the standard deviation. And values that are not significant, they fall between these two ranges. Mu minus 2 sigma and mu plus 2 sigma. So here is the range rule of thumb. It says to simply find the standard deviation by using the range rule of thumb, you would simply take your range from your data set, and the range would be the maximum value minus the minimum value, and you would divide by 4. All right, so let's take a look at an example. And this is problem number 29. All right, so this is problem number 29. And if I click on this question help, notice there's no question help for whatever reason. There's simply an ask my instructor. For some of the problems in this course, you'll notice that for the question help, there just simply is no view an example. Okay, and that's a part of the book publishing company. All right, so here we're given the race speeds in minute for the top 8 cars in a 200-mile race, and they're listed below. We're asked to use the range rule of thumb to estimate the standard deviation. All right, so how do we estimate the range rule of thumb? Okay, well, I'm going to bring up my calculator. And I'm simply going to enter in the data. So I'm going to go into stats. We want to edit the list. I'm going to press enter. I'm going to use list 1, and I'm going to clear everything out of that list. And I'm simply going to enter in my data points. Okay, so I'm just going to check back through these. 181. Okay, so now in order to find the standard deviation by using a range rule of thumb, I would simply take my range, which is my highest value minus my lowest value, and I would divide by 4. I'm going to go back to my home screen. So that's second in mode, which is quit, and I'm going to clear everything out. So I'm actually going to use a calculator to find the largest and the smallest value. So I'm going to go back into, well, I'm going to go into list, which is second in stats. I want to scroll over to math, and my first and second functions are my minimum and maximum. I want the maximum value, so I'm going to select the max function, and I want the maximum value of list 1. Right, so I'm hitting second and 1, which is list 1. And that'll give me my maximum value, which is 189.2. I can also find a minimum value. I can go back into lists. I can scroll over to math. That first option is the minimum, and I can find my minimum. I can take those two values, 1, and I'll use a set of parentheses, 189.2 minus 175.6. I'm closing off my numerator. I want to divide by 4. And that gives us our range rule of thumb estimate for the standard deviation, 3.4. Now here's another way I can do it without actually repeating these values. I can actually use a calculator, the min and max functions, to calculate them. So here's what I mean. I'm going to put a set of parentheses. I want to go back in the list. I want to find the max of L1 minus the minimum in list 1 and I'm going to close off my minimum function, close off my numerator. I can divide by 4, and I get the same value, okay, 3.4. Okay, so that's how you would calculate the standard deviation by using the range rule of thumb. Okay, now we're going to talk about z-scores, and z-scores are going to be a really big part of the next section, well, the next chapter really. And a z-score is basically a standardized value between -3 and +3. And we'll talk more about a z-score. So once again, a z-score is a standard score, a standard value. So here's the formula for the sample, which is mainly what we're going to use in this course. Z, which is short for z-score, that's equal to x, and x would be a data value from your list, minus x bar, which would be the mean, divided by the standard deviation. Right, this calculation will give you what's called a z-score. Or if you're dealing with population parameters, z is equal to x minus mu divided by sigma. Now, when you talk about a z-score, z-scores are usually rounded to 2 decimal places or the hundredths place. Here's some important properties of a z-score. A z-score is the number of standard deviations that a given value x is above or below the mean. Z-scores are expressed as numbers with no units of measurement. Here's one that's sort of important. A data value is significantly low if the z-score is less or equal to -2, or significantly high if the z-score is greater than +2. And we'll touch on this third point in just a second. The fourth item says if an individual data value is less than the mean, its corresponding z-score is a negative number. So as we begin this road of z-scores, here are just 4 properties of a z-score that we're going to start with. Okay, so one thing is that if the z-scores, they actually run between -3 and +3. Z-scores that are less than or equal to -2 are significantly low. Z-scores that are greater than or equal to a +2 are significantly high. So let's take a look at an example. Okay, I'm going to go back to the homework. This is actually problem number 36. All right, and here again, number 36 doesn't have a viewing example. All right, it says the mean height of a basketball team is 6 feet with a standard deviation of 0.2 of a foot. The team center is 6.9 feet tall. Find the center's z-score, and then we're asked to determine if his z-score is unusual. Okay, so we're going to take them one at a time. First, we're going to find the z-score. So I'm going to go back to our document camera. And here was the formula for a z-score. A z-score is equal to x minus x bar divided by the standard deviation. So from our problem, we were given a data value, which is x, and that data value was the center's height. It said the team center was 6.9 feet tall, so x is equal to 6.9. X bar, which is the sample mean, we were given as 6 feet. Okay, that problem reads the mean height of a basketball team is 6 feet. S, which is the standard deviation, is 0.2, 0.2. All right, so just for a point of clarification, if I go back to our shared screen, okay, it says the mean height is 6 feet. So we substituted x bar for 6. The standard deviation is 0.2. So we substituted s for 0.2. and we're given that the team center is 6.9. So our X value is 6.9. All right, so now we'll calculate the z-score. So z is equal to 6.9 minus 6 divided by 0.2. And if we calculate that on the calculator, 6.9 minus 6 divided by 2 by 0.2. We get 0.9 divided by 0.2. So we get a z-score of 4.5. So that center, who is 6.9, has a z-score of 4.5. All right, so that's the z-score. Now we're asked if his z-score is unusual. So I'm going to go back to the shared screen. And it says that a z-score is significantly high if it's greater than 2. So our z-score is 4.5, which is greater than 2. So that would be a significantly high height. So if I go back to the question, we have his z-score is 4.5, and yes, his score is unusual because it's greater than 2. All right, so any questions on how to calculate a z-score? All right, I'm going to go back to the shared screen. Okay, I'm already on the shared screen. Okay, so here again, this is just a chart just showing that significantly low is less than -2 and significantly high, or z-score is greater than 2. Okay, next we'll talk about percentiles, and percentiles are basically measures of location, and they're denoted by the capital P with the subscript. So this P sub 1 would be the first percentile, P sub 2 is the second percentile, P sub 99 is the 99th percentile. In order to calculate or find percentiles, I'm not actually going to do that in this virtual class, but I will show you where you can find an example. If you go back to Blackboard under videos for homework problems, you see a chapter 3 video on how to find percentiles. So I'm just going to click on this. And I actually go through an example on how to find the percentile of a data set. Okay, this is like a 5-minute video, and there's a couple of problems toward the end of this chapter. They ask you about percentiles, but they don't actually give you a viewing example. Okay, so for those percentile type questions, I'm going to refer you to the Blackboard website, and under videos for homework problems, because I actually do a homework problem, you can find that located here. We also have what are called quartiles, and just so you're familiar with these things, we're going to talk about these quartiles shortly. Quartiles are measures of location, and they're denoted Q1, which is the first quartile. Q2 is the second quartile. It's also known as the median. Right? In order to calculate the median of a data set, you will put all of your data values in order. You would take your middlemost value as your median, and that's the same as Q2. And Q3 is the third quartile. And it basically divides your data set into groups of about 25%. All right, there is a 5-number summary, and we're going to talk about a couple of ways to find this 5-number summary. So here's what a 5-number summary is. It's the minimum value of a data set. It's the first quartile of a data set. It's the second quartile or the median of a data set. It's the third quartile of a data set, and it's also the maximum value. And so if you're asked for a 5-number summary, these are the 5 values that the 5-number summary consists of. All right, let's take a look at an example. Here we're asked to use Verizon Airport data speeds to find the 5-number summary. All right, so in this list of data, we're given the data speeds at an airport, right? If you're on a Verizon network. Okay, we're given these values. So here's our process. We're going to take these values. We're going to put them in as list 1. And we're simply going to compute the 1 variable statistics. And within that 1 variable statistics, it should give us the 5-number summary. Okay, so I'm going to clear out my home screen. I want to enter this data into the list. So I want to go into Stats and Edit. So I'm going to hit Enter. I'm going to clear out all of the entries in list 1. All right, and we're going to put in these values. Okay, I'm going to check my numbers. Okay, so you should have 20 numbers in total, and I think I have everything in there, right? Okay, so once you put your data into your list, I'm going to go back to my home screen, so that's second and mode, which is quit. I want to go into stat. I want to scroll over to calculate. I want to calculate the one variable statistics. Now you'll notice up until this point we put in two parameters, a list one and a list two. Here I only want to put in list one, and I'm going to hit enter. All right. Now if you're using a Ti84 calculator, that one variable statistics function will look a little bit different. So give me a second. I'm going to put it into my 84 handheld. All right, I'm going to go back to the document camera for just 1 second. Okay, so I put everything into list one in the calculator, just as in the virtual calculator. I want to go back to my home screen. If I go into stat and over to calculate and one variable statistics, notice it looks a little bit different. So my list should be list one. For frequency list, I'm going to clear that out. So when we were doing the frequency distribution, we used like list one and list two. Since we have just the data set, my frequency list should be clear, and I'm going to hit calculate. All right, and you should see the exact same values. Okay, I'm going to go back to the share screen for just 1 second. And here's where I can find the 5-number summary. If I scroll down, so I'm going to simply hit the down arrow, I'm given the minimum, which is 0.8. I'm given Q1, which is 3.4. I'm given Q2, which is the median. So it doesn't actually call the median Q2. It lists it out as the median, but you should know that Q2 and the median are the same. I'm given the third quartile, 10.5, and I'm given the maximum number in the set, 11.6. All right, so in order to find the 5-number summary, you can simply enter your data into a list. From that list, calculate one variable statistics. Next and lastly, we're going to talk about a box plot, and it's sometimes called a box and whisker plot or box and whisker diagram, and it's basically a summary, a graph of the 5-number summary. So a box plot would consist of the minimum value, Q1, Q2, Q3, and the maximum value. So let's see how to calculate a box plot using the calculator. Now we're actually going to use the same data set as before, but there's a couple of quirks to graphing a box plot. All right, so you should already have the same data set in your list 1. So I'm simply going to just clear out my home screen. Now, since we're dealing with the graph section of the calculator, I'm simply going to go into y equals, and if you have any functions in the y equals, so let's say if I have 5x plus 6, you want to clear those functions out. So I would simply find the appropriate function and then just clear it out. So y1 through y10 should all be blank. Okay, that's the first thing. Clear out your y equals. Next, in order to graph the box plot, I want to go into what's called a stat plot. If you look above your y equals key, you should see the word stat plot. And on this Ti83 it's orange, but I believe on the Ti84 it's a blue key. So I'm going to hit second and y equals. So all of the stat plots should be turned off. Right, there's what, 5 or 3 stat plots. I'm going to go to this very first plot 1, and I'm going to hit enter. The first thing we want to do is we want to turn the plot on. So it's highlighting on. I'm going to simply hit enter. So now on is being highlighted. Next, you want to choose your type of plot. So for our box plot, I'm going to choose this plot. And I'm going to highlight that with enter. Now I see an X list, and you want to leave that as list 1. You also want to leave frequency as 1. Right, so if I just double check this with the Ti84, you should see the exact same palette for stat plot. Now here's how you actually graph the plot from this point. Once I have everything highlighted and selected, I want to hit stat. Excuse me. Once you have everything in your stat plot, you want to hit zoom. I want to scroll down to zoom stat, and you want to hit enter. And this gives us a box plot. Okay, if you're using a Ti84, just to show this on the Ti84. So I have my, everything's cleared out of y equals. I went into second and stat plot. So my plot is turned on highlighted. I'm going to highlight the plot, the box plot, I'm going to hit zoom, and I'm going to scroll down to zoom stats, and we get the exact same plot. Okay. So what are we actually looking at? All right, so this thing is plotted on an X and a Y axis. So this would be my X axis. And I'm going to reconstruct this drawing, the box plot. All right, so we're seeing something that looks like this on the box plot, and then we have a number line. Now this point right here, this is Q, this is your minimum value. From where our box begins, this first line of our box, this is Q1. Okay, I want to actually call this the middle, because this thing, it won't actually lie directly in the middle of your box. This is your median, or Q2. The last line of our box, this is Q3. And this last point is the maximum. All right, so if I go back to my one variable statistics, so I'm going to hit stat, scroll over to calculate. We want one variable statistics. All right, the list is list 1. There's nothing for frequency list, and I want to calculate. So from what we saw earlier, the minimum should be 0.8. On my number line, on the number line, you do see these little tick marks at the bottom. This should correspond to 0.8 on that number line. Q1 is 3.4. My median is 6.35. The third quartile is 10.25. And then the maximum value is 11.6. So let me just make a note. This is not to scale. All right, but as you're looking at the box plot on your calculator, all right, those points should correspond to this number line. All right, so I guess I'm going to ask at this time, are there any questions about what we went through today? Okay, now as far as the test is concerned, the test is on Monday. Can you have the entire day to complete the test? If you have any questions about anything, if you send me an email, I will post a response. Okay, I'm going to go back to the shared screen for just 1 second. Okay, I'll post a response in this videos for homework problems. The problem that's actually in here now, someone had a question about And I'll go back and actually look up the problem number. It was a problem, a question about percentiles. I remember it was toward the very end of the homework set. Okay, and I did this short little video. So if you have any questions about any of the problems, I know there may be some problems that only have for the question help to ask your instructor. For any of those type problems or anything else, even it does have a view and example, just shoot me an email. I will respond and I'll put the video here. Also, from this point going forward, whenever I put a new video in this video for homework problems, I will send out a mass email to the class. Just let them know that, you know, such and so problem is in this particular section. All right, so any questions about anything else up to this point? All right, well, if no further questions, I will see everyone on next Wednesday. Okay, thank you and have a good weekend.